So in today's lecture, a good evening to you all before we start. In today's lecture, we are going to be looking at sleeping sickness and the Chagas disease. Is any of these diseases familiar to any of us? So I had Alex, Franco, and Eguma raise up your hands. Eguma, you have something for us? Is any of these diseases familiar to you? You can open your mic.
I think sleeping sickness is a sickness which is familiar. It flies, and to some extent, it normally the central nervous system.
Thank you so much, Mr. Eguma. Do we have any other contribution on top of what Eguma has given us? So let's look at a brief overview of sleeping sickness and the Chagas disease. Sleeping sickness is known as the African trypanosomiasis. And then the Chagas disease is known as the American trypanosomiasis. So let's first look at sleeping sickness in particular. Sleeping sickness is caused by Trypanosoma brucei, and it is transmitted by flies. It primarily affects the sub-Saharan Africa. And then the Chagas disease, which is also known as the American trypanosomiasis, is caused by the Trypanosoma cruzi. It is transmitted by the triatomine bugs, also known as the kissing bugs. It's endemic to Latin America, but it spreads to other regions in the world due to migration. Both of these diseases are known as neglected tropical diseases. A lot of attention has not been given to them in terms of research. They can cause significant morbidity and mortality. And as we've seen, both are forms of trypanosomiasis. I think that gives you a clear overview of what we are going to be talking about. These diseases are mainly common in rural populations, particularly in areas with these flies, and then the kissing African trypanosomiasis and flies, and the fly first. The human African trypanosomiasis is also known as sleeping sickness, as we've discussed, and it is caused by the protozoan parasites that are transmitted by the infected flies, and these parasites are called the Trypanosoma brucei. So this disease takes on two forms depending on the subspecies of the infecting parasite. So we have two subspecies, which is Trypanosoma brucei gambiense, and then Trypanosoma brucei rhodesiense. The Trypanosoma brucei gambiense causes the chronic form of the disease, and it's reported in 92% of cases. So here, a person can be infected for months or even years without major signs and symptoms. So by the time the symptoms emerge, the disease is often very advanced within the central nervous system. And usually the central nervous system is already damaged and affected. For this other second subspecies, the Trypanosoma brucei rhodesiense, which causes the acute form of the disease, is reported in 8% of the cases. The first signs and symptoms of this disease always emerge a few weeks or months after the infection. The disease just develops rapidly with multiple organ failure, including the brain. So the most common form of heart is the chronic form. As we've said, it is reported in 92% of the cases, and the other form, the acute form, is reported in just 8% of the causes of the cases. Since this since this chronic form of disease does not show symptoms early, it's very hard to diagnose and also treat. So they may require specific skills for a clinician to be able to treat this disease and diagnose this disease. So let's first look at the sassafly. The sassafly belongs to that genus and order, and it occurs only in Africa. And it is the vector for the African trypanosomiasis in humans. And also, it carries a similar disease in animals called the nagana. The sassaflies have distinguished forward projecting piercing proboscis on their heads that are capable of puncturing the skin, penetrating it, and then feeding on the blood. So they feed on the blood for both humans and animals. Let's go ahead and look at the life cycle of this sassafly. There are 4 stages of the sassafly. And like in our previous lectures, for various vectors that we've looked at, the sassafly is no different. It also has its life cycle occurs in 2 hosts, in the sassafly and in the human. So it has the sassafly stage and then the human stage. So when the sassafly takes a blood meal from the human, it injects the metacyclic trypamastygotes into the human. So when these trypamastygotes are injected within the human, they transform into the bloodstream, and these trypamastygotes are carried to other sites of the body within the bloodstream. The trypamastygotes multiply by binary fusion in various body fluids, for example, the blood, the lymph, and the spinal fluid. So these trypamastygotes in blood are then taken as a blood meal into the sassafly when a sassafly bites the human. So within the sassafly's bloodstream, the trimastigotes transform into the procyclic trimastigotes in the sessefly's midgut. The procyclic trypanosomatigotes multiply by binary fission still and leave the midgut and transform into the epimastigotes. So the epimastigotes multiply in the salivary gland and they transform again back into the metacyclic trypanocygotes that are later transmitted to the human when a sessefly takes a blood meal. So that is briefly the life cycle of a sessefly. I hope we are following.
Yes.
So since we are all following, um, let me first look at this briefly. Let's be continuing. I wanted us to answer questions. Let me ask just a random question. So which stage of this Trypanosoma brucei life cycle occurs in humans? Does anyone have an idea yet? Which stage of this parasite occurs in the human stage?
Yes, can I try?
Hello?
Can I try?
Yeah.
Yes, Alex.
Hello.
According to me,
Yes,
it's
Alex, please go on.
stage three,
Let's
where
first
it
hear
we,
from Alex Franco.
yeah, I mean it is stage three where we talk of the trimagotes multiplied by capillary fusion in the various body fluids like in the blood and in the lymph. That's
Okay,
according to me stage
thank you,
three.
Alex. Okay, thank you, Alex. Franco is just different from Alex's.
Hello.
Yes, Franco.
Yeah, I think it's just the same. It is a metacyclic trypanomastigotes, which is in human.
Okay, thank you very much, Franco. It is the metacyclic tripomastigotes that occurs in humans. And now, Alex, can you tell us the stage that occurs in sesseflies? Alex, can you tell us the stage that occurs in the sessefly?
I think for me it could be stage eight.
Hello.
Okay, Franco, you have your hand up.
Oh yes. The stage in the sessile is start from stage 6 after taking the blood meal. Then the metacyclic promastigote, trypanomastigotes transform into the procyclic trypanomastigotes. Thank you.
Okay, Franco, thank you very much for that submission. I hope everyone has understood those different
Yeah.
stages. Okay, we can continue. So heart is mostly transmitted through this. I think when I talk about heart, everyone follows that. I'm talking about the human African trypanosomiasis, not the heart, the human body. So the heart is mostly transmitted through flies, but there are also other possible transmission ways. Heart can be transmitted from mother to the child. Since these trypanosomes can cross the placenta and infect the fetus. There is also mechanical transmission by other blood-sucking insects, although their epidemiological impact is likely marginal. Accidental infection in labs via pricks has also been reported with contaminated needles, and a few times sexual contact has also led to the transmission of these trypanosomes. So initially, the trypanosomes multiply in the subcutaneous layer, as we've seen in the life cycle, through the blood and the lymph, and this is called the first stage, which is the hemolymphatic stage. It entails fever, headache, enlarged lymph nodes, joint pains, and itching. Later on, in the second stage, these parasites cross to the blood into the central nervous system, causing the meningoencephalitic stage, which is also known as the hemolymphatic stage. There are obvious signs where there are behavioral changes. That is where even the sleepiness comes from, confusion, poor coordination, sensory disturbances, and disturbance of the sleep cycle. So when this sleep cycle is disturbed, then you get sleeping sickness. You begin sleeping all the time, every time. So without any treatment, heart is usually fatal, although rare cases of self-cure have been reported. So this map is showing the incidence of this heart in Africa. And you can see the different distribution of the incidence in Africa when you look at the scale. So the countries reporting no cases are highlighted in green. Countries reporting under 100 cases are highlighted in blue. Countries reporting between 100 to 1,000 cases in brown, and those countries highlighted in red report more than 1,000 cases. So you can see how distributed the instance of this disease is in Africa. How do we prevent no vaccine against the African sleeping sickness. But what you can do is to avoid being bitten by the tsetse flies. So experts have recommended vector control measures, including use of insecticide-treated nets, insecticide repellents, and traps. Wearing protective clothing such as long-sleeved shirts and pants. So since these tsetse flies can bite through the material, these clothes have to be made of thick fiber. So it is recommended to wear kachi or other neutral colored clothing also, since tsetse flies are attracted to bright and dark contrasting colors. So when traveling in a jungle, it is also recommended to avoid riding in the back of jeeps, pickup trucks, other open vehicles, and also stay away from bushes. These tsetse flies are really attracted to the dust created by moving vehicles and animals. So when you're on the back of those vehicles, tsetse flies can easily bite you. And during the hottest parts of the day, the tsetse fly will rest in the bushes. They will not bite if disturbed. So if you're moving through the bushes, they'll definitely get disturbed and bite. So regular screening and treatment programs have been set up in endemic regions, and also public health education and awareness campaigns have been carried out to reduce risk and promote early treatment. So that is all about the tsetse fly and the sleeping sickness. Yes, please.
When I saw the map you sent me,
So on the map, let's go back. I'll move. Yeah. So your question is, why is it common in some countries and not common in other countries?
yeah,
Is that your question?
yeah, this is my question. Yeah,
Can someone answer that question for me? Franco?
Hello.
Yes,
Hello.
Dennis. Yes, Dennis.
Yes. Okay. Yeah. What I can say, it differs due to the demographic, how do I call distribution? Because we know this is not evenly distributed. It favors some specific kind of regions. So, if we look at this map, the north
is full of desert of which it cannot uh, these supplies cannot survive in a desert area, which means they look at a breathing pattern or breathing area that make them to survive most. So if you look at this map, you look at Sudan and South Sudan, even Uganda, these are the areas that are very cold in the area. So I think this is a favorable area where they can survive. So thank you.
Very detailed explanation. I hope, Michael, you're satisfied. Let's move on to the Chaga disease. So anyone has something to say about the Chaga disease before we dive deeper into it? Remember, when you participate in the session, things get deep, you get a deeper understanding. Anyone who has something to say about the Chaga disease? Can I choose randomly? Let me choose someone who has not said anything. Justin, you've not told us anything today. And Grace, you can also say no, I don't have anything to say instead of keeping quiet. Justin and Grace, George. Michael, you can mute if you have nothing to tell us.
I go ahead.
Yes, you can.
Yes, George. Michael, are you telling us in the session things get deep, you get a deeper understanding? Anyone who has something to say about the Chaga disease? Can I choose randomly? Let me choose someone who has not said anything. Justin, you've not told us anything today. And Grace, you can also say no, I don't have anything to say instead of keeping quiet. Justin and Grace, George. Michael, you can mute if you have nothing to tell us.
I go ahead.
Yes, you can.
Yes, George. Michael, are you telling us?
I have no idea about these diseases, but it's caused by parasite, and it's most mostly found is bugs and also fecal contain the parasites, mucous membranes, broken skins.
Thank you very much, Michael. At least you've been able to Thank you very much. George, do you have something to top up? George, you had something to tell us? Michael, please mute. No, please mute your mic. Thank you so much, George, for that contribution. Egumba, you have your hand up.
Yeah, I think to reflect back on what you said also at the introductory phase, this chaga, which is also being caused by the, is it cruci? So it is also a chronic form of the African trypanosomiasis is an acute form. That is the pre-partition. Thank you. Over to
Thank
you.
you very much. Wonderful submission. Michael, can you please mute? Because we are getting some background noise. Thank you. So, as discussed earlier in the introduction, and by all of you who have made contributions, Chaga disease is also known as the American trypanosomiasis. And it is Anosoma cruzi. It is primarily transmitted to humans through contact with the feces of the infected triatom bugs, also known as the kissing bugs. The disease can also be spread through blood transfusions like the sleeping sickness, mother to contaminated or drinks that are contaminated with the fecal material of these bugs. This disease can cause a range of symptoms including fever, fatigue, body aches, swellings on the site of the infection, and in severe cases, heart and digestive system complications can be seen. And if untreated still, this disease can be life-threatening. So why are these bugs called kissing bugs? These bugs are called kissing bugs simply because they prefer to bite humans on the face, particularly around the mouth and the eyes. and they are very active and feed on their hosts mainly at night. That is where the name came from. They like just the face. So these bugs carry the Trypanosoma cruzi parasite. They have cone-shaped heads and oval bodies and are either black or brown. They belong to the subfamily Tritomini within the family Redovidae. They are characterized by their long snout and proboscis. So these species are commonly found in domestic settings and they prefer feeding on domesticated animals. So let's look at their distribution. These bugs are commonly found still in the US, particularly in the southern US. And and can enter human domiciles, kissing bugs. It's not any different from what the major these protozoans are carried through the fecal material. So the metacyclic trypanosoma is again when these so after biting you they release the fecal material and then with the parasites. These parasites will penetrate through that wounded skin or mucous membrane onto the human. So when they invade the host cells, they transform to amastygotes, they multiply and rupture the host cells. So when they rupture the host through the bloodstream, they can then be ingested during the feeding of the bug, and then they go back to the bug system and that of the bug, and the cycle continues. So these epimastygotes in the midgut where the metacyclic trypomastygotes develop that are later transmitted or expelled through the fecal material. So the bite itself is not the actual mode of transmission. We should remember that after feeding on the host, the kissing bug defecates on the person or animal. So this contact with the fecal material and enters fecal material into any. I hope that is clear.
Yes.
Okay.
I'm just saying it's okay.
So let's move on. 70 million people are estimated to live in areas of exposure and so looking at the distribution of this
Degradation and the approach of using those trapping nets, I think, is one way of not completely destroying their breeding grounds, but to trap. For sure, that is very correct and result in total clearance. Because currently we are also fighting global warming, which has been attributed mostly to environmental degradation. So for sure, in every effort that we engage, we need to take environmental protection